All right, so this is 242, valid anagram. So this one's not too bad. It helps to know what an anagram is first, though. So an anagram is any word that can be rearranged to make another word. So if we have the word race, we can change it to care. So, and we have care, obviously we can change it to race or whatever, a bunch of, I don't know if there's any other words actually we can make from those two. But that's what an anagram is. So, given two strings s and t, write a function to determine if t is an anagram of s. So, what we can do, if you look at the input, s is an anagram, and then t is nagaram. Output true. So basically, we can see that this word or nagaram is literally made up of the letters that form anagram. So that's true. If you look at rat and car, though, that is not the case. So there's two ways to do this. The first way, if we put the scaffolding in here, the first way, right, the first thing that we can check for sure to know whether or not something is an anagram is by the length, right? So if we have the word car or care and like boats, these are obviously not anagrams because the lengths aren't the same. So the first thing we can do is if len of s does not equal len of t, then return false. So that's just gonna stop us from wasting time, checking however we do with boats and care if they're even anagrams, because they're not by default. So there's two ways to do this from when you get to this point. The first way is we could sort s, and then we could sort t. So these are two strings, right? And if let's just say we had, let's just do care and race again. And race, if we were to sort these in alphabetical order, both of these would turn into the same thing, hopefully, right? So we'd have A, C, E, R. And then from this point, it should be pretty rudimentary to figure out whether or not these are anagrams of each other, right? We just have to iterate through s. If letter does not equal letter in t, then return false. If you make it through this loop, then you return true, right? Otherwise, if they didn't match letter by letter, then they would be anagrams. So just to implement that really quickly, we'll see that we can do s equals sorted s. In Python, you can kind of just use a sorted function. Save you some time. And then t equals sorted t. So that should be done for us there. Then we can do for letter in s. We can do if letter. Oh, no, we want to do, actually, it would be easier if we do it this way. For I in range of len of s. Then we can do if letter sub t does not equal to follow our scaffolding from earlier. Boom. Let's make these match up. Letter sub t, oh my god, what am I doing? S sub I and T sub I. If these two letters aren't equal, then return false. It's not an anagram. So if we run this, this should work. This is pretty good. Then we can run all the tests. First time doing this problem, by the way, actually true. False is not defined. Oops. That's my bad. And so while that's running, we'll see that this should pass. It's going to be fast in most of them. But what's the time complexity and the space complexity of this, right? So at first glance, you might think, well, okay, we're going through the list of the length of s, one character at a time, comparing the letters. If they're not true, then it's not an anagram. It should be linear time, right? But it's not, right? Because we have to sort the strings first. And if we assume that the most efficient sort is used, then this is going to take n log n time, which is far worse than linear time. So this algorithm is actually not bounded by this linear time iteration here. It's bounded by both of these sorts. So this is going to take, at worst case, n log n time. The space complexity, though. Space complexity here is pretty good. Technically this is in place, I guess, or constant time. But a better way we can do this in linear time instead of n log n time is with a dictionary. So the same base case is going to apply here. If the words aren't the same length, right, then they're not anagrams. The second one we can do here is we can do this in we'll do this in linear space, but where n is going to refer to the length of the first string, And then we're going to iterate through the second string and check whether or not a character exists within the dictionary. If it doesn't exist, then it's not an anagram. And if it does exist, then we're going to decrement the occurrences that we made earlier. So the first thing is going to be to create a dictionary of letters, of letter to occurrences, right? If we create a dictionary of letter to occurrences for word S, let's just say, let's do for the word boats, let's do for the word care, and then we'll just pretend that we have this dictionary. And we'll just do C-A-R-E. And then what we're going to do here, well, we'd made this dictionary, right? We'd iterate through the list to create this dictionary for the first word. We'd iterate through the second, word, and we'd say, well, is for the letter in T, so let's just say the word for T is race. We'll say, okay, if dict sub R is in the dictionary, which it is, then we're going to decrement it. So that's going to be equal to 0. Then we're going to go through A, C, E, and then what you'll find is that if a word is an anagram of another word, this dictionary should equal 0 once you're done. If we ever go through -1, or if we ever go to anything less than 0, you'll find that there's a mismatch. So that's one way we can do it there. You can do this with 2 dictionaries, but using one dictionary and just decrementing when you find an imbalance, anything less than 0, then you'll know that they're not anagrams. So just to make that here, we're going to say ldict, which is letter dict. We're going to set it to the default value here, and we're going to say for letter in S. And then we're going to say, oops, if letter in L underscore dict, then we're going to say L subdict, subletter is equal to L subdict subletter plus 1. So we're just going to increment the number of occurrences. And then if it's not in the dictionary, then we're just going to make it, right? We're going to set its occurrence to 1. So that's going to make the dictionary here. Now we can iterate through the second word. So we can do for, but we're going to want to use, let me see. Let's see. I think we can just do it like this. For letter in T, we're going to iterate through the second word. Now, if letter in L underscore dict, what we're going to do is L subdict is going to, L subdict subletter is going to be equal to L subdict letter minus 1, because we want to decrement, right? If the letter is not in the dictionary, then we know just from what we said earlier, like if we have to check if the letter Z is in care, the dictionary of care, it's not going to be, they're not anagrams, so we return false. The thing we have to do after here, which is going to be pretty much the brunt of the logic, which tests whether or not this is an anagram in linear time, what we're going to do is going to say, if L subdict subletter is less than 0. So we just decremented up here, right? Or we didn't, but we just decremented up here if the letter was in it. Now, if we decrement it and the letter is less than 0, the occurrence of the letter is now less than 0, which means the words aren't the same, or they aren't made of the same. They don't comprise of the same number of elements. So we can return false here. Now, if you pass this test and this test, then logically you must be an anagram. So if we test this should be okay. Oops. It's my bad. Yeah, so the first test passes, and this should be good. And so what we're doing here instead is we're trading kind of space for time, because the first one we're doing kind of like in place or constant place, whatever you want to say. So it takes linear time to create the dictionary, and our dictionary is going to scale with the size of the first word. And so it takes linear time to iterate through the second word and test whether or not that's true. So this is going to be an algorithm that takes linear time. Space-wise, it's also going to be linear space because our dictionary scales with the input of the first letter. The first word. So that is 242 valid anagram. Oh, and the follow-up actually is, what if the inputs contain Unicode characters? So the hash map solution is perfect for this because it doesn't really matter like what the character is. I mean, if we can do like, you know, the L sub dict sub Chinese character, L sub dict sub anything else, it's not really going to matter. We'll still be able to find it in the dictionary. So this solution works for that as well.